Right, multi-protocol label switching is not only for fast rerouting, it is also used for various other uh, applications like layer 2, layer 3 VPN, and etc. So we can see that just only based on the label, the packets are moved over the tunnel. It can be layer 3 or layer 2. And whenever you think about IGP protocol for underlay support, you need to make sure you got single area if it is OSPF and ISIS. Um, if it is ISIS, even if you have multiple areas, make sure you got L2 everywhere. Otherwise, there won't be routes to form neighbor. Same case with OSPF and EIGRP. If you are doing summarization, when you got multiple areas, you will do summarization. If you do summarization, make sure you don't summarize for those address that BGP uses as the ID to peer with.
Okay. Can I ask a question?
Yes.
Can you explain, or can you just clear up overlay and underlay, please?
Okay. Underlay is the physical network. Underlay is the network that you visualize, you can see with your eye. You can see for our fire routers in our lab inside the ISP network, you saw like 4 or 5 routers with some wires, isn't it? Those are
Yes.
underlays, physical network. And what is the routing protocol that you use in underlay?
You can use
OSPF,
OSPF.
or ISIS. Okay, so whenever you have ISIS or OSPF, you're okay to have multiple areas, but if you're planning for an overlay, what is overlay? If you're planning for a VPN, you need to make sure you don't have summarized route or you don't have a default route. You need to make sure you got precise route in the routing table to reach the peer address. Otherwise, BGP cannot form neighbor. For this reason, if you are using for this reason, if you are using ISIS, use L2 everywhere. So the routes will be seen in the routing table. If you are using OSPF, don't do summarization if you are using multi-areas. Single area, no problem. You will not be doing summarization within an area. Any question? So overlay in short means VPN. Overlay is the VPN. How many routers you will see if you have overlay? Only 2 routers, PE1 and PE2 in our lab environment. Just 2 routers. All the middle routers are hidden. Now, MPLS is a transport mechanism. So it can also transport the traffics that are coming through the tunnel encapsulated with another layer of MPLS called a service label. So whenever you have layer 3 VPN application or layer 2 VPN application or segment routing or traffic engineering, you will see always more than one MPLS header, more than one MPLS labels. Example, in MPLS layer 3 VPN, you got a transport label to move the packet hop by hop in the underlay, and you got BGP label to transport the packet overlay. Also in layer 2 VPN, you got transport layer as we spoke for every router hop by hop within the ISP. And to identify the remote layer 2 PE circuit, we have virtual circuit, VPN label, VC, virtual circuit label. So labels not only we use with BGP, and MPLS LDP. Labels are also used by other technologies like segment routing. See, segment routing itself is a, is a big training. Uh, Many Air Force got trained from me on this topic called segment routing. Indian Air Force as well as US. I've trained them segment routing. So segment routing is a special topic because it's an advanced level of MPLS, you can say. Segment routing with IPv6, no need MPLS. SRv6, which is nothing but segment routing version 6. The labels are carried on the IPv6 header itself. So there is no need for an additional MPLS header for IPv6. For IPv4, you always need MPLS in order to do segment routing.
Can I ask a question?
Yes.
Okay, I'll go back to L2 VPN, and since L2 VPN is considered to be in the layer 2 part of the network, is it faster than L3 VPN?
Of course it will be, but the reason why someone will go for L2 VPN is their local office and branch office are in same subnet. They do not want to have layer 3. I repeat. Between the head office and the branch office, there is a big service provider. Even though there is a service provider, they do not want to do layer 3 routing. They want to do layer 2 switching for some good reason. What may be the reason? Maybe they are having VMware and having vMotion, for which the layer 2 should not change in the middle. The source and destination MAC address should not change in the middle. If you do routing, the source and destination address will keep changing for every routing device, for every hop. So depending on the requirement, I have seen some airports in UAE, like Oman, Muscat Airport, Salalah, which is also next airport next to Muscat, in between Muscat and Dubai, Emirates. So all these airports, they got layer 2 MPLS VPN. I have seen them using because I delivered training for them. So you see, there are organizations between the airport, they do not want to have routing because they got a lot of VMware virtual machines.
Okay.
So it is not just fast or slow, it's the demand, it's the need. It is the need. They want to have a layer 2 communication between site, not layer 3 routing. Or in another way, we can say security. You see, when you do layer 3 VPN, we need to advertise our networks to PE router. Yes or no?
Yes. In layer 2, yes.
No, you're confusing yourself. In layer 3 VPN, customer
Layer 3.
need to advertise the route to the VRF. Yeah.
Yes.
So
Yes.
provider will know about your internal network. So if you feel that it's a threat for you, if you are not comfortable to reveal your internal networks to provider edge, then you can go with this layer 2 VPN, where you no need to advertise any routes to the provider. You no need to advertise any routes to the provider. Routes are going to be only on the customer edge routers. Through the provider only, layer 2 communication happens. Do you understand what I'm saying? Or shall I draw a diagram?
Draw a diagram.
You see, whenever we have layer 3 VPN, we have a PE router and we got a layer 3 VPN, and this customer route is advertised, and you can learn that in the VRF table. Yes, let's say 1.1.1.1. You will see that here in the table 1.1.1.1, and it will not be seen in any of the middle routers because it is VPN. And you will see that 1.1.1.1
Right.
again here, and then it is sent here. Likewise, when this guy advertised 2222, you will see 2222 here, you'll see 2222 here, and it comes here. Is it yes? No? Okay.
That's true.
So if you say, hey, I'm not comfortable to advertise my networks to the provider. I don't like to advertise. What if my provider becomes a hacker? What if my provider becomes a hacker? So I'm not comfortable. If you feel like that, then you can go with layer 2 VPN. What's the difference? Because it's layer 2, you will not be advertising any network. And very important thing is the tunnel. The tunnel is going to be from here to here. So whatever sent out, let's say here 10.0.0.1, here 10.0.0.2, whatever is sent out will go directly through the tunnel to outside. There is no VRF, there is no routing, there is no encapsulation, decapsulation. Just additional MPLS layer it gets. It is not going to, sorry, there is encapsulation, decapsulation, but it is only MPLS encapsulation and decapsulation. There is no layer 2 encapsulation. Your layer 2 address, the source address of this one will be seen here. So say, for example, MAC address AAA, MAC address BBB. So when this guy receives the packet, he will know that I'm receiving from AAA because there is no change in layer 2 in the path. Did you understand, or should I explain more with some more example?
No, I understand.
All right. So let's move on to the applications that are there in the industry which uses MPLS service. Now, MPLS layer 2 VPN, MPLS layer 3 VPN, inter AS MPLS VPN. This is purely ISP related. Between the autonomous system, I'm going to have MPLS VPN. This is your office in Houston, and there is another office in Canada, and you got many ISPs, not just one, many ISPs. So inter AS MPLS. So when you do VPN, layer 3 VPN, not just one ISP. What you did in the previous enterprises class is only one ISP. It's not inter. Yeah?
Right.
Yeah. Here you're going to have MPLS from this end to this end, even though there are many ISPs. So this is another application. And then carrier supporting carrier, CSC, carrier supporting carrier, exactly something related to this. One carrier supporting another carrier. Right? They need again MPLS. MPLS traffic engineering with RSVP, resource reservation protocol also needs. And there is something called seamless MPLS or unified MPLS, which is nothing but segment routing. Right, so these are the things that the service provider focuses on. Now, layer 2 frame is carried over MPLS transport. So the service is layer 2 frame. Transport is over MPLS. Same MPLS infrastructure can have all about MPLS application services at the same time. So if one router is doing L2 VPN, it doesn't mean that you cannot have L3 on the same router. You can have. You can have MPLS VPN, L2 VPN, means you can have layer 3, layer 2. You can have traffic. You can have all of them on single router. Nothing wrong. They are all different applications. You can serve a layer 2 VPN to one customer. You can also have another customer layer 3 VPN. And you can also have another customer with traffic issue or fast rerouting. If you are extending MPLS towards an access domain of the backbone, then you can have end-to-end MPLS backbone without the need of protocol translation.
Explain.
Yeah. Protocol translation. If you are extending MPLS towards an access domain of the backbone, then you can have end-to-end MPLS backbone without the need for protocol translations, meaning you no need to have any sort of layer 3 protocol translations like BGP to OSPF, OSPF to BGP, like what you did in the previous class, like redistribution. So those layer 3 kind of thing is not because it's end to end. When I draw you a diagram, layer 2 diagram, okay, here it
Right.
is. Whatever goes in here it goes out here. It's end to end, and there is no
Right.
need for any additional protocol. So this guy has got no idea what is really happening here. He simply sends the packet. The tunnel is right facing the customer, not behind the PE. Basically, it's another way of explaining layer 2 VPN. So two different layer 2 VPN architecture provides similar services. Different Metro Ethernet form is one layer 2 VPN architecture. Layer 2 VPN can be point to point also. Uh, this is Metro Ethernet, meaning kind of point to point. MPLS layer 2 VPN can be point to point, can also be multi point. Point to point is also called as VPWS. WS stands for wired service wire. Wire means what? How many points you will have? Only 2 points, right? Point to point. Only one wire. Another one is VPLS. LAN means what? Will you have just 2 points?
No.
You will have multiple ports. LAN switch, LAN. So VPLS means virtual private LAN service, which is also called as layer 2 multi-point VPN. VPWS is layer 2 point-to-point VPN. Both VPWS, virtual private wired service, which is point-to-point, and VPLS, which is LAN service, can be accomplished in two ways. One, this is what I was talking about. You can have these two in two ways. One, in both the method, transport tunnel is created between PE device via LDP protocol. So your encapsulation protocol is LDP. You can also use BGP.
One second. One second. You said your encapsulation protocol is LDP. Isn't it the
MPLS.
same as? Okay. That's
MPLS
okay.
is nothing but LDP.
Okay.
So in both VPLS and VPWS, you can use MPLS as an encapsulation protocol, or there is something called a compel method, compiler method, where we create a pseudo wire and we use signaling protocol as BGP. You can use BGP instead of label, MPLS.
Explain. I don't understand. It's in
See,
compiler method, the pseudo wire is signal via BGP.
see, we are talking about layer 2 VPN, correct? In layer 2 VPN, to transport, the transportation can be using the label, can also be simply by using the MAC address. MAC address will be advertised using BGP. So this end device MAC address is given to this end device, and tunnel is here, layer 2 VPN tunnel. So A's MAC address is seen in here, B's MAC address is seen in here. So these MAC addresses are distributed using BGP. Now you can do layer 2 communication because you know the MAC address. Your circuit is ready. Or for this MAC address, you can have LDP to assign a label, and label can be used to move the packet. It's your choice whether to have label or without label. L2 VPN can be with MPLS, can also be without MPLS.
And what does pseudo wire mean?
Pseudo means, which is nothing but VC, which we saw some time back, virtual circuit. Virtual circuit, pseudo wire, all are same. Pseudo means what? Is it real or virtual?
Virtual.
Virtual. Yeah. So pseudo, see, there is a command called pseudo wire. That's why they're using the word here.
Okay.
Pseudo wire is a command actually on the command line when you configure layer 2 point-to-point VPN.
Okay.
So there is also another method called Martin method. Pseudo wire is signaled via LDP. So here in compiler method, pseudo wire is signaled using BGP. In Martin method, pseudo wire is signaled using LDP. So as I was telling, you can either use LDP or BGP. So here we can see that customer edge router, provider edge router. There is an IP and MPLS running inside this, and then P routers run only MPLS. There is no IP. Customer edge is a customer equipment which can be managed by service provider or customer depending on the agreement, service level agreement. So you know what it is. Now let's go to the next one. And these are all simply explaining, you know, these fundamentals. What is P router? What is P router? Okay.
Yeah. Yes.
Packet layer gets two label in both MPLS layer 2 as well as layer 3 VPN. Other label, which is also called as topmost or transport label. Transport label is the one which is, within the autonomous system. Whereas the inner label is for the VPN tunnel identification, which is called service label, isn't it? We know this. Okay, Martin method, you know, it uses the LDP, and compile uses MPBGP for virtual circuit identification. I was telling you, pseudo wire and virtual circuit are same. See, now here they are not using the word pseudo wire; they're using virtual circuit. So we'll be using both the Martin as well as Compella methods in our lab. Right, so here we know this difference already. L2 VPN, virtual private. How do you read
service,
this one? Virtual private?
service.
Exactly. Wired service. This one, LAN service. See, because it's a LAN service, you must need have Ethernet as the underlying technology, which we always have. But sometime in some productions, you will see point to point, a serial wire, or HDLC, a frame relay. This you don't see ATM and all very old. Or sometimes you can also see Ethernet. So whatever you may have, VPWS will work, but for VPLS you must have
Ethernet.
Ethernet only. VPWS can carry almost all layer 2 payloads, like this frame blah 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 blah, as can be seen from the above diagram. VPLS can carry only Ethernet, although there is an attempt in the IETF of other little, never mind, so not proven. VPWS is nothing but point-to-point wired service. PA devices learn only VLAN information if the virtual circuit type is VLAN. If the virtual circuit type is Ethernet, then PA device does not keep any state. So if you are using VLAN, see, virtual circuit type, if it is only for one particular access port, then it cannot have any virtual LAN information. See, this is just talking about point to point, just point to point. If you want this point to point to act as a trunk link, then it is not possible if it is simply Ethernet. It can carry only one particular traffic, one VLAN traffic. When we go to the command line, I'll make it clear for you, this one. So PA devices learns only VLAN information if the type is VLAN. If it is not VLAN, if it is simply Ethernet, then it won't maintain those VLAN information. It won't maintain, the device won't keep any VLAN info. That's what it means. Okay, here we can see pseudo wire or virtual circuit, layer 2, and layer 2 tunnel, transport tunnel. Okay, so now this is normal C router sending packet, and the traffic enters
What does AC mean?
the
What does
circuit.
AC mean?
Here actually means circuit. So we got two circuits attached from different customer, blue and red. And blue talks to blue and red talks to red. It is because they are marked with some labels, different labels. There is only one egress point for pseudo wire because it's wired service. You cannot have more than one PE. Just two routers participating. So that there cannot be more than one egress. If this is ingress, then this should be the egress. There's no other egress. There's only one egress point for VPWA service, which is the other end of the wire, pseudo wire. Thus, PA device does not have to keep the MAC address to the pseudo wire binding. They no need to maintain MAC address table because whatever the remote device that you want to reach, this is the only option. Why do I unnecessarily maintain the MAC address of the remote guy? Whether I learn the MAC address or not, that's the only hope for me to go out. isn't it? Yeah. So PE device does not have to learn the MAC address of the customer. See, this is for VPWS because it's point to point. But for VPLS, it have to maintain the MAC address. So, but in VPLS, since the service provider emulates the bridge service, meaning layer 2 switch service to the customer, the MAC to the pseudo binding is necessary. The destination might be any PE since the service is multi-point. You may have multiple Ps. P devices keeps the MAC address of the customer. Although there is PBB, VPLS, which provides more scalable by emulating learning the customer's MAC address, it's not widely implemented. So there is a technology called provider backbone bridging, which is kind of statically configuring the tunnel endpoints, but it's not widely used. We use like learning through BGP or MPLS dynamically. In order to create VPLS, full mesh or pseudo wire is necessary. So you need to create full mesh pseudo wire. Now, this is a layer 2 technology. So you will not have VRF. Instead, what do you have? Virtual forwarding interface, VFI, not routing instance. You are not going to have routing instance. Instead, you have forwarding instance. Virtual forwarding instance, which is nothing but a switching instance. See, this is red line is like a VLAN 10. Blue is like a VLAN 20 if this is a layer 2 switch. Yeah. So the VFI, virtual forwarding instance, also known as VSL, virtual switching instance, is equal to the VRF in layer 3 VPN. It is used to identify the VPLS domain per customer. So for each customer, you have a separate L2 circuit. All right, so I think we'll start this again next
How
class.
many more slides leave?
VPLS. Oh, I have to